Okay, Bismillahirrahmanirrahim. Assalamu alaikum, dear participants. Welcome to all viewers of this introductory seminar about the design philosophy of CubeSats. In fact, we will mostly talk about ICUBE-N, which inshallah be the first national and multi-university CubeSat of Pakistan. I am Rehan Mahmood, and I briefly talk about the importance of CubeSats in STEM education, along with the history of CubeSat development in Pakistan. In fact, IST is the only university in Pakistan which has developed and launched a CubeSat, ICUBE-N in 2013. After that, Dr. Rizwan Mughal, who is the project manager of this national CubeSat, ICUBE-N, will educate you about the CubeSat technical details and also will highlight different mission scenarios. And finally, Dr. Khurram Khurshid, the co-PI of this project, will highlight the participation possibilities of different educational institutes in this ICUBE-N project. In fact, well, we have several positions still open for the development of ICUBE-N. So please join us. Okay, dear participants, please remember to register even if you are watching this seminar after today, that is 17th of October 2020. And register at the link sstr.space/register-event. It will help us to reach you for any future trainings, tutorials, and collaboration opportunities. You can ask the questions anytime during the live event by typing your question on the Ask a Question button, which is located on the upper right menu bar. We will try to answer the most liked questions verbally in the end. But please remember to vote for the questions so that we can select the most relevant and interesting ones. So what does a CubeSat do? The very basic definition of CubeSat, it is a cube-shaped satellite standard which supports the learn by doing philosophy for students. And you can get more details on cubesat.org. One U of this CubeSat standard is a 10 centimeter cube, and 2U, 3U, and even 12U are also possible with slightly larger dimensions. So it's like a standard cargo container, and it is up to the student that what to pack in it. It may be a camera to take the images of the Earth, some sensors to measure the Earth's gravity, radiation, and any other scientific stuff. In short, a lot of experimentation can be performed using CubeSats, and experimentation means learning. Not only learning about the space environment, but also the knowledge you obtain during the development of CubeSats, including concepts about electronics, mechanics, controls, and then ultimately how to protect that thing, that stuff, or the CubeSat from the harsh environment of space. And even the CubeSat fits perfectly on the philosophy of Confucius. That is, I hear and I forget, I see and I remember, I do and I understand. This is what CubeSat is doing for education. So there are a lot of things and new concepts to learn while developing CubeSats, though it requires a handsome amount of funding. But for this part, we have a plan for you. How? Number one, it is by educating you. Number two, providing you a training equipment. And number three, involving you in a CubeSat development project, ICUBE-N. The details of all this stuff will be shared by Dr. Khurram Khurshid in a while. So the logical question here is that, do we have the right capability of developing and managing a CubeSat project? The answer is fortunately yes. Our team in IST developed the first CubeSat of Pakistan, ICUBE-N. In fact, IST is the first and only university in Pakistan to develop and launch a CubeSat, ICUBE-N, in 2013. though it was not possible without the full support of our national space agencies SUPARCO and HEC. In fact, apart from ICUBE-N, our team played active role in the development of PNSS-1, the SPARCO satellite, and SSS-2A satellite from EBSCO. The experience our team learned during these developments will be utilized to manage and develop ICUBE-N. And obviously, the technical support will be provided by SUPARCO, while financial support will be from HEC and Government of Pakistan. Recently, HEC has established a National Center of GIS and Space Applications in IST, consisting of 7 affiliated labs all over the Pakistan in various universities. Small Satellite Technology and Research Lab, SSTR, is one of them and established in IST. We at SSTR are basically developing a 3U CubeSat, ICUBE-N, and this National CubeSat of Pakistan will be developed in collaboration with various educational institutes of Pakistan. We are planning to perform some unique experiments on ICUBE-N with your help and support. And we will also provide an in-house developed CubeSat training equipment to certain universities, even without any cost, in order to develop the basic know-how of satellite engineering. Added to that, we inshallah enable Pakistani institutes to access various satellites and even ISS via IST ground station through some sort of internet connectivity. In near future, we are also planning to have a series of lectures related to the basics of satellite engineering on weekly basis, highlighting the various aspects of satellite development. So please join us as will be explained shortly by Dr. Rizwan and Dr. Khurram Khurshid that how to join us in this project. Okay, so finally, ICUBE-N. I will briefly introduce the ICUBE-N here, and then I will request Dr. Rizwan to further explain the technical aspects of the ICUBE-N. ICUBE-N will have all the typical subsystems of a satellite and will reveal, and definitely we will reveal further technical details in the future seminars. ICUBE-N will perform some unique experiments, as I told you earlier, some of which will be specified by students like you. And you can be a part of this project in several ways. It might be some sort of technical help, some management help, any promotional help, and even any financial help. Though it is a funded project, but we have expanded the horizon of this project so that various Pakistani students can be involved in it. So we might need some funding in future or might not. I don't know exactly at this stage, but there is a possibility. So now for further details of CubeSats and ICUBE-N, I request Dr. Rizwan Mughal to take the lead. Over to you, Dr. Rizwan.
Okay, thank you very much. Dr. Rizwan. Let me share my screen. All right. So first of all, I would like to thank you all for joining this session. This is basically the introductory session of ICUBE-N, and also we would like to brief you about what the CubeSats are and which are the typical subsystems that the CubeSats host and which are the missions that CubeSat perform. So I am Dr. Rizwan Mughal, and I am currently affiliated with Institute of Space Technology. I have experience of designing and developing CubeSats in Italy as well as in Finland, and of course I have also contributed in many Pakistani CubeSat projects, and which include this PNSS, which is Pakistan National Student Satellite from Sparco. Then EBSCO is another body, which is a regional body. So we are part of the EBSCO SSS, which is Student Satellite Project as well. And then currently we are initiating this ICUBE-N, which is the National CubeSat of Pakistan. Okay, so first of all, I would like to brief you about the Cubesat standard. So just to tell you that Cubesat is an innovative platform. Why is it? Because it can be designed with very low cost and in quick time. So if we talk about the classification of the satellites, so typically satellites are classified in terms of weights. So if a satellite is about 1000 kilogram or less, this is classified as a small or medium satellite. If a satellite weighs more than 1000 kilograms, then it is typically called a big satellite. So the small or medium sized satellites are further classified, as you can see in the slide, that if a satellite weighs between 100 kilogram to 1000 kilogram, it is typically called a small or medium satellite. Then if it weighs between 10 and 100 kilograms, it is classified as a microsatellite. If a spacecraft weighs between 1 and 10 kilograms, this particular class of satellite is called nanosatellite. And then if the weight of the spacecraft is less than 1 kilogram, then we call it picosatellite. Now, since the start of this century, some professors from US universities, they started thinking about designing the satellites. They started to train the students to design the satellites. So they came up with the idea of standardizing the satellites. So they came up with the idea of a CubeSat. So what CubeSat is a standardized satellite, which is approximately 10 centimeter by 10 centimeter by 10 centimeter. If a spacecraft is 10 by 10 by 10 centimeter, and if roughly it weighs 1.3 kilograms, then this is called 1 unit CubeSat. So if we see, you see this particular class of satellite falls in the category of nano satellite, like this. So if we call 1 unit CubeSat, it is 10 by 10 by 10 centimeter, and the weight is roughly 1.3 kilograms, and it falls in the category of nanosatellite. Now, if you add another unit, then it becomes 2 unit. If you add another unit, then it becomes 3 units. So the standard defined a lot of configurations of CubeSats, including 3 units, 6 units, 12 units, up to 27 units. So if a CubeSat is 27U, then theoretically it will be called a microsatellite. So we define the standard that a CubeSat can either be a nanosatellite or it can be a microsatellite. Now this is the anatomy of a CubeSat mission. So first thing you need to launch the CubeSat, if you have built it, is this launch vehicle. So launch vehicle has multiple stages. So you separate multiple stages in different altitudes of space, and then in fact, ultimately you launch the satellites in space. So once you launch, then the next thing is which orbit you launch. Then the next task is to operate the CubeSat or the satellite itself for the mission life you design for. So typical mission life for a CubeSat is 3 years or less than 3 years. But for bigger satellites, this lifetime, of course, is much bigger. Traditionally, if you design the CubeSat for 3 years, it can definitely last more than 5 years. But in order to not create junk in space, there is some sort of standard that the spacecraft you have to ensure that you bring the spacecraft down to the atmosphere within 15 or 25 years life. So now we have defined what the CubeSat is. So CubeSat or even these small nano or micro satellites, they are very small sized spacecraft. As you can see, one picture of the satellite. So it can be only few kilograms. So then, because it's quite miniaturized, it is cost effective to build. So if we talk about the big satellites, we talk about millions or billions of US dollars or euros in the manufacturing. But the current trend with the CubeSat designs is that they're quite low power, low cost. Low cost means that they can be designed in less than 100,000 US dollar budget. So with this particular budget is low cost in terms of space. So, and then of course they can also be launched quite effectively, cost effectively. So why they can be launched cost effectively? Because they are standardized. Standardized mean that they can fit into a standard deployer. So you can see that this particular figure tells you a deployer. So you can put 4 of these, standardized satellite in this dispenser or deployer. Though these are the standardized deployers, means that in one rocket you can launch multiple satellites. Multiple means you can launch even 100 satellites or even more than 100 satellites. So if a single launch vehicle or rocket can take more than 100 satellites, it means that the cost is shared between each unit. So effectively, the launch cost is lower as well. So this picture demonstrates a class of SpaceX satellites. They are not CubeSat standard. They are bigger satellites, but still you can see that even how many satellites are fitted into this particular launch vehicle. And these satellites were launched into space. So they, you can see that they were also being tracked by some astronomer last year in Sweden. So you can see how a train of satellites can be seen if caught from the ground. So this is another video demonstration how satellites are launched. So this particular launch vehicle is from India. So Alto 1, which is the first Finnish satellite, it was launched on board this particular launch vehicle. So you can see that the satellites are being deployed to the space, and they're quite. You can see that how the deployment of the satellites can be. So they can even be launched from the International Space Station. So if you are familiar with International Space Station, good. If you're not, then I would like to search. I will ask you to search what the International Space Station is. It is typical. It is basically a station where astronauts or people live in space. So it is flying approximately 400 kilometers above our Earth's surface, and this particular module is the Kibo module, which is the Japanese module of the International Space Station. I'm trying. So there should be a video. Okay, anyways. So you see that a CubeSat, which is Brazilian CubeSat, is being launched from the International Space Station. So this was a 1-unit CubeSat. So there's a program of UN. They also provide free launch to one CubeSat or 2 or 3 CubeSats every year from the International Space Station, and this particular CubeSat was deployed as part of that. Okay, so here you can see that.
2, 1, arc.
So here you see that the CubeSat is being deployed from this Kibo module of the International Space Station. All right, so now we talk about deployment. I talked about that the satellites or these CubeSats can be deployed in large numbers. Now there have been multiple types of spin-offs or new companies that are coming up with new approaches to launch. So this particular type of approach is to launch the satellite to your desired orbit. So the launch vehicle typically launches the satellites to a single altitude. For example, it will go to 500 kilometers and launch all of the satellites there. But what if you want to launch your satellite to 600 kilometers, for example? And what if you want your satellite to launch in different, inclination in the orbit? So what are you going to do? So these types of quite low cost companies are there. They actually host the dispensers, and they can put your satellites there, and they can go to the desired altitude where you want to launch, and they launch the satellites for you. Then you can even launch the satellites using an aeroplane. There is a company called Virgin Orbit. They are trying to launch the satellite from. So actually, they have these types of launch vehicles, which is shown here in this particular picture, Launcher 1. So they aim to launch this particular Launcher 1 from 45,000 feet. That is the cruising altitude of this 747. And if they launch this launch vehicle from there, it means that the launch will be quite easy, because most of the gravity effect has already been taken care by this plane. So as you can see that there are various types of deployments, and you can choose any type of deployment based on your mission needs. We talked about the Cubesat standard. It's quite, low cost and effective to build. Because it is low cost and effective to build, so even the universities are building these types of satellites. So universities students can design, build, launch, and operate the satellites. So there are multiple, examples of students building the satellites and launching and operating them. So, so this is basically one of the idea of this seminar, to engage you people to come and be part of our project, which is ICUBE-N, ICUBE National. Build the satellite, design the satellite, launch and operate it. So basically, this particular project will give you a lot of opportunities to be part of the team, and even to lead the teams. So on your left side is a picture demonstrating Pakistani team. So of ICUBE-N, and on the right side of the picture is a Finnish team. The Finnish team launched their first satellite, which was called Alto-1, back in 2017. So since the Cubesat standard has revolutionized the space industry, so many countries are launching their first satellite as Cubesat. So if I was talking back in 1999, I would think of only few countries that would be space countries, that would be called space countries. US, Russia, China, India. Only these types of big countries were the space countries. But today, like to this date, almost even very small countries are building and launching their satellites. And once they have launched they can be classified as space nations. So this is the list of the countries. They have launched their first satellite as Cubesat. So even this Switzerland, Finland, Estonia, South Africa, and of course the list is much bigger. So I could list only few countries here. So these are the countries whose first satellite was the Cubesat. Some photographs you can see. All right, so now we know about the Cubesat standard, how to launch them, and how to operate them. Now talk about what is inside, what is typically inside the Cubesats. So now the Cubesat standard is well defined. This is one thing. So if you want to start a Cubesat project, you will find a lot of help, a lot of documentation, a lot of standardization on how to get started and how to build the satellite actually. So this particular slide gives you a picture of the CAD or the actual structure design of the Cubesats. So for which of the faces of the satellite would be called x minus x plus y minus y, and where you are going to host solar panels, where you are going to put different types of switches, where you are going to put the deployment switches, separation switches, and how much are the dimensions of each axis. So they are quite easily, searchable even on simple internet. So if you want to start your CubeSat project, this is the first step to see what is the CubeSat standardized specification document. Now, any satellite, any satellite has two types of subsystems. The first one is called platform. Platform is basically the infrastructure of the spacecraft. कि आपकी जो satellite है वो कौन सा infrastructure provide कर रही है, और जो दूसरा जो main element होता है, that is called the payload. Payload is actually the intended mission of your satellite or CubeSat. So what you want to do with this particular type of mission. So if you want to capture the images of the Earth, you will have a camera payload, for example. If you want to, for example, track some aeroplanes or some sort of some sort of other search trackable things, then your mission will be tracking. If you want to search some minerals or some other types of if you want to search some minerals, then the payload will be your spectral imager, for example. So if we want to classify the satellite, we classify two basic subsystems: the platform, which is the basic infrastructure of the spacecraft. Platform क्या है कि इसमें you will have all the necessary subsystems. For example, the satellite has to provide power. Then you need to have a power subsystem. So you will have to design this particular power subsystem. Then the satellite has to communicate with your Earth station or with your ground station. Then you need to have this type of communication subsystem. It means that this particular subsystem provides you access to this space and also from space to ground. So both from ground to space link and from space to ground link, both of these. So this subsystem is typically classified as TT&C, or telemetry, telecommand, communication subsystem. The next platform subsystem is called AOCS or ADCS. ADCS or AOCS are attitude, determination, and control subsystem. So you want to know your you want to know where you are pointing and how you are pointing at a particular time. So this subsystem has got a lot of sensors and actuators to point and first find where you are pointing and then control the orientation of the satellite. Then we have another subsystem which is called onboard data handling subsystem. So this subsystem typically is responsible to manage everything. For example, it will have an onboard computer. So this computer is managing every action. For example, if the camera has to take images and then those images have to be sent back to the ground. So all of this task management is done during this through this OBDH or onboard data handling subsystem. And then of course the structural subsystem is the main holding strength of the satellite. So if we talk about the platform subsystems, there might be multiple subsystems, and the main aim of a satellite designer is to either design one of these subsystems, few of these subsystems, or all of these subsystems. Of course, one cannot design all of these subsystems, but a team can design. So that is why we are introducing you with this technology. Come and be part of one of the subsystem of your own choice, where you feel that you will be able to contribute in that particular subsystem. Payload, as I told you, that payload performs the intended mission that you need to perform. These are some of the payloads that I have just mentioned here. For example, the payload can be an optical camera to capture the images. Images of the Earth. So you can, for example, take the images of the Earth. You can also capture the images of the horizon, for example. You can also If you want to capture the images of stars, then it becomes a telescope. So there might be multiple types of payloads with satellite. This is another type of payload listed here to track aeroplanes. So this is called ADS-B payload. Another type of payload that tracks ships is typically classified as AIS. Then there is another payload option which is shown here is Gamma Link. Gamma Link provides an inter-satellite link between two satellites. This is of course a wireless link. Then the payload might be some sort of technology demonstration. For example, if you want to demonstrate some propulsion technology, for example, that can also be a payload. So these types of payloads can also go to the platform subsystems. Then another payload might be this GPS or GNSS or this Baidu receiver. And so there might be many multiple options. So so these are only few ideas. Now I also invite you to think some out of the box idea, and if you have some very interesting idea, just let us know, and we will definitely be very happy to further work with your idea, and that idea might be selected as a mission of ICUBE-N as well, because the payload or the actual mission of the ICUBE-N is still open. Now I give you further insights of each platform subsystem. So what are the typical design philosophies? So if I talk about each subsystem, there are two design philosophies. One is to procure a commercial off-the-shelf module, as you can see on this side of your screens. So these are two commercial onboard computers. So onboard computers can be procured because they are standardized. They can be procured and connected very easily with the rest of the subsystems, or they can be designed by ourselves in-house. So now there are clearly two streams. One is the commercial subsystem procurement. On your right sides of the screen, you can see an in-house development. So if we need to develop the subsystem in-house, then we have to actually come up with a very detailed block diagram, and then we have to actually design these small modules and test multiple prototypes and qualify that particular system to be flown on the satellite. So both of these areas are open, but for our satellite mission, we are aiming to develop in-house the subsystem. So if you are interested in developing this onboard computer, of course, you can join the OBC team. Typically, an onboard computer hosts some microcontroller or FPGA, and then it is interfacing with a lot of memories. So you also need to interface. You also need to have interface between different, peripherals. So you need to have a lot of communication protocols implemented. So all of these things are implemented on this onboard computer. Once you have onboard computer, then you can accomplish this onboard data handling subsystem. So onboard data handling subsystem is actually communication of OBC with the rest of the platform and payload subsystems. This is just an example. Satellite onboard data handling subsystem. So this particular onboard data handling subsystem uses redundant buses. Redundant means that because in space you cannot go up and repair the thing, you have to think well in advance. If a fault propagates to one of the main subsystem, then how would you make sure that your system does not fail at all? So you can duplicate some of the resources. You can think about new design, software design techniques or hardware design techniques. So for example, you can see that this is the bus communication between subsystems. There might be multiple options. You can use CAN, you can use UART, you can use some well-known protocols to route data between different subsystems, and this is the typical stack connector. So if you are good at embedded programming side of things, then this is the subsystem for you. The next subsystem is tracking telemetry and commanding subsystem. Typically, it's called TT&C. Again, there might be two clear options on this side of the screen. You can see this system can be procured commercially, commercial off the shelf, or it can be designed. So if we want to design the subsystem, we need to think about the RF front end design, both for transmit and receive, because I told you that the TT&C subsystem has to take care of both uplink, means from ground station to the satellite, and from satellite back to the ground station channel. So two channels, it means that you have to design your RF electronics accordingly. So if you are good at electronics, RF electronics, this can be a subsystem for you. And then another accompanying module with TT&C is the antennas. So if, for example, there are certain frequency bands that we use, that we are allowed to use for satellite communication, typically UHF, VHF, or S-band. So we need to design the antennas accordingly as well for these types of this TT&C subsystem. So the next subsystem is the power subsystem. Electrical power subsystem provides, so it generates power. It is used to condition power. It is used to store power, and it is used to distribute power. So all of these subtasks are part of this EPS subsystem. There are multiple types of, the solar panels are typically body mounted on the satellites. But if the power requirement of your subsystem is much higher, then you can also think about deployable structures. You can see these three different types of deployable structures are also shown, just to let you know how you design these deployable structures. Again, mostly we use solar panels to generate power, and we use battery subsystem and power conditioning and distribution subsystem to condition, distribute, and store power. Again, there are two clear streams. We can procure commercial subsystems, or we can build our own, because the main core idea of ICUBE-N is also to educate you in the satellite technology. So the best education comes through design, and if we opt for designing an actual subsystem, then this is the best experience that you will get. So again, we intend to design the subsystem as well. ADCS is another platform subsystem, which is attitude, determination, and control. So you want to find your orientation in space. For finding the orientation, we need certain sensors. One of the sensor is shown here. This is sun sensor. So sun sensor finds the tells you where the sun is with respect to your body reference. And then there might be magnetometer as well, which tells you the magnetic field at that particular location. And if you have these two measurements, you are able to find where you are or how you are orienting in space. And in order to control your orientation, you use a set of actuators. One of these types of actuators shown on top of the screen, which is magnetic. These are the coil based. You can use coils to generate torque and align yourself with the magnetic field, or you can use reaction wheels. You might see these three reaction wheels here. So you can use reaction wheels to spin. If you spin the reaction wheels, you are able to control your orientation. Again, there are certain commercial options available in the attitude determination subsystem, and there are options to design these subsystems as well. Structure subsystem, because we are concentrating on this 3-unit CubeSat, and 3-unit CubeSat is a sort of CubeSat which has this type of structure. You can see there are a variety of structural designs in the upcoming missions, including this 3D printed structures as well. We can use the raw aluminum, and we can machine the structural parts ourselves, and then we also need to do a lot of testing before using it, that whether this will survive the launch vibrations, or whether how much is the integrity of the structure, or whether the structure is able to survive the thermal environment in space or not, things like that. Okay, so this is the an example of a cumulative platform. which is platform plus payloads. So this is Fossil 1 satellite. I'm also part of this team, and this has got 3 different payloads. And the main idea is to put everything in such a way that it conforms to this 3-unit structure. So this is just to tell you how. All right, so now there are different design philosophies if you talk about designing. So first, once you are new, you have to start with this breadboard model. Once you have tested the interfaces using breadboard model, the next step is to design the actual PCBs. Once you have designed the PCBs, you can connect them together, all of the subsystems on the flat table. So this is typically called flat set model. And once you have, qualified all the interfaces and made sure that testing and the necessary testing has been done, then you go for the engineering model. Engineering model is basically the flight representative model where you do a lot of testing and qualification. And then finally is the flight model that is actually flown in space. Okay, so I would skip this slide for the time being because this gives you a whole, overall summary of how the design and testing procedure for a CubeSat works. But once I would definitely want to elaborate this particular slide or this particular design philosophy in upcoming seminars. But just to give you the main idea that on this side of the screen, you can see that there are certain platform and payload subsystems shown. So these can be in-house developed. Some of them are in-house development, and some of them are commercial subsystem developments. Now this slide tells you which are the necessary steps to test the in-house subsystems and which are the necessary steps to test the COTS or commercial off-the-shelf subsystems. Then we do regular reviews in different phases. For example, this is the integration of everything. So you integrate everything in a CubeSat at this stage. Before integration, you have certain flags here. It means that you conduct certain reviews. And once you pass all those reviews, then your satellite is good to go for launch. And once you launch, then you still have to do some further reviews of the mission and post-launch as well. All right, so now there might be certain thesis topics on these platform subsystems, payload subsystems. You can even design any platform subsystem, or you may come up with an idea of designing a payload. For example, you can say that I would like to design a payload, an imaging camera, a magnetometer payload, some other, scientific payloads, etc., etc. Now, since we should have by now some very basic understanding of the platform and payload subsystems, now I give you a very short review of few missions with the CubeSats that are mostly being done for the time being. So this ship tracking application is quite, famous. So you use this AIS receiver. AIS is automatic identification system. So the receiver itself is very small. It just is one PCB, like 10 by 10 centimeter in dimensions. And once you have this particular receiver on board your CubeSat, then you are able to do ship tracking. And there are certain CubeSats that have already done this type of tracking missions. For example, you can see this 1-unit CubeSat from Norway. This is called AAUSat-3. This hosted this AIS payload, and you can see the signature of the tracking that it conducted throughout its mission life. So these are, you can see that which are the quite famous shipping routes. For example, the most populated areas can be seen here, that how much populated these particular shipping routes are. So they give you a useful information. Then there is another application which is called aircraft tracking. You can use this ADS-B receiver, which is also being used quite famously in many satellites. Some of The payload options, commercial payload ADS-B receivers are shown here, and the satellite that hosted both ADS-B and AIS receiver was this Lemur 1. And then, of course, there are certain other CubeSats that are doing these types of tracking. All right, so next one is spectral imaging, radiation monitoring, and plasma breaking with a single CubeSat. So this CubeSat is Aalto 1, which was the first Finland's mission. So this particular CubeSat hosted all of these three payloads. You can see the imager payload on the right bottom side of my screen. So this is a spectral imager plus a visible camera imager. So both of the cameras are integrated in very small compact form, and you can see the image taken by this payload of the same area. One of the image is this visible image, and the other one is this spectral image. Then the next payload it has is this radiation monitor, and you can see this global view of the Earth and the measurement it has been taken, and quite clearly you can see that it was able to do quite useful measurements. So it means that a CubeSat can also have multiple payloads. So if you have some design ideas about the payloads, or you come up with some ideas, even we can think of multiple payloads. Then Planet, if you have heard about this Planet satellites, they typically design a lot of CubeSats, which are approximately 3 units CubeSat, and they do Earth observation and remote sensing with these types of CubeSats. So basically, Planet develops 3 different sizes of the satellites: Planet Scope, Rapid Eye, and SkySat. Of course, Planet Scope is the one which is CubeSat sort of standard. So you can see on the bottom right of the screen 3 types of images taken by 3 different satellites. So an image resolution of approximately 3 meter resolution, a 3 meter ground resolution can be captured from the CubeSat type of satellite that they design. So next type of mission idea is microwave remote imaging, remote sensing, radiometry. This particular mission, which is called Tropics, this is from US, and they use this radiometer to identify different channels, radiometer channels, and they measure in different bands. Further, of course, information can be seen through their website, but yes, this is the idea as well that you can have with the CubeSat. So this is a 3-unit CubeSat, actually 2-unit CubeSat and 1-unit payload. The payload is a rotating radiometer in this case. Then you can even design a radar in a CubeSat. So this is also a US CubeSat, and this CubeSat is basically 6-unit CubeSat. You can see they actually deploy this type of radar from a 6-unit CubeSat. You can so actually this so a sort of mechanics is involved, because once you have to launch, you cannot deploy, so it has to be inside this form factor, 6-unit form factor. But once the satellite gets deployed in space, then this antenna is deployed. So a lot of research and development is going on in these types of deployment architectures. People are trying to deploy a lot of big solar sails, and they want to use these big active surface areas to deorbit the satellites, to use them as the solar panels, to use them as the big antennas. So these types of ideas are also most welcome for our CubeSat mission. All right, so now since we have a very basic idea of what the CubeSat or small satellites are, then what are the main classifications of the CubeSats, and what are the main subsystems of a CubeSat, which design philosophy is typically used. Now, about the ICUBE-N or ICUBE National CubeSat, Dr. Rehan has already, elaborated during the initial few slides. So it is most probably going to be a 3-unit CubeSat. Of course, this is not compulsion. We can even go in higher form factor if we have some very useful ideas, but at the moment we target a 3-unit CubeSat. For the platform, we will mostly focus on in-house development. We will focus the development activity in IST Islamabad, and for payloads we are quite open for ideas, and in order to involve all of you in the design and development of the CubeSat, I like you to join ICUBE-N program. So this is all from me, and now Dr. Khurram will conclude with the final words as well. Thank you for your patience, and over to Dr. Khurram.
Thank you very much, Dr. Rizwan. So, listening to Dr. Rehan and Dr. Rizwan, it has become very apparent that ISTS has very relevant and very mature experience in small satellite design and development. We have been part of various national and international projects that include ICUBE-N, which was the first satellite that was launched back in 2013. Then we have worked on ICUBE-2. ICUBE-2 का इंजीनियरिंग मॉडल हमारा बन गया हुआ है और इसका सिर्फ इंजीनियरिंग मॉडल ही तक स्कोप था. इसके अलावा हमने PNSS जो कि स्पार्को का प्रोजेक्ट है, पाकिस्तान नेशनल स्टूडेंट सैटेलाइट, उसके अंदर काफ़ी मेजर रोल प्ले किया है. और इंटरनेशनल प्रोजेक्ट्स में IST हैज़ बीन वेरी एक्टिव विद द EPSCO प्रोजेक्ट्स. EPSCO बेसिकली एशिया पैसिफिक स्पेस कॉरपोरेशन ऑर्गेनाइजेशन है, जिसमें पाकिस्तान के अलावा चाइना, टर्की, ईरान, पेरू, थाईलैंड, मतलब इस तरह कुछ 13-14 ममालिक शामिल हैं. तो पाकिस्तान उसमें एक मेजर रोल प्ले करता है EPSCO में. और जो SSS-2 है स्टूडेंट स्मॉल सैटेलाइट CubeSat, उसमें IST एक मेन लीड रोल प्ले कर रहा है. तो काफ़ी यानी अरसे से, पिछले डेकेड से ही IST के अंदर सैटेलाइट्स में काम हो रहा है. और अब स्पेशली इस सेंटर के बनने से और SSTR लैब स्पेशली एस्टेब्लिश होने से, जो ये HEC का मेगा प्रोजेक्ट है, इसमें ICUBE-N एक नेशनल लेवल का CubeSat होगा, जिसमें IST के अलावा बाकी यूनिवर्सिटीज़ भी पार्टिसिपेट करेंगी और पूरा यानी इसको एक नेशनल फ्लेवर मिलेगा. तो आप लोगों के पास बहुत सी अपॉर्चुनिटीज़ हैं. आप लोग ICUBE-N की टीम को अगर ज्वाइन करते हैं, कुछ अभी तो जॉब पोस्टिंग्स भी आई हुई हैं, आप लोगों ने अखबार में ऐड देखा होगा, तो अगर आपने उसके थ्रू अप्लाई किया हुआ है तो बड़ी अच्छी बात है. लेकिन उसके अलावा भी बड़ी अपॉर्चुनिटीज़ हैं. आप ICUBE-N की टीम को ज्वाइन करें फॉर वेरियस टास्क, जिसमें सब सिस्टम्स की डिज़ाइनिंग, जो अभी डॉक्टर रिजवान ने तमाम मुख्तलिफ सब सिस्टम्स बताए हैं, उसकी डिज़ाइनिंग में आप पार्टिसिपेट कर सकते हैं. पेलोड डिज़ाइन स्पेशली, ये कुछ क्वेश्चंस भी आ रहे थे स्पेस साइंस स्टूडेंट्स के, या जो बाकी भी तमाम स्टूडेंट्स हैं या रिसर्चर्स हैं. पेलोड डिज़ाइन एक मेजर काम है कि सैटेलाइट ने करना क्या है एक्चुअली. तो उसमें आपके आइडियाज़ और आपके डिज़ाइन इनपुट काफ़ी हेल्पफुल हो सकती है. आप पूरा मिशन डिज़ाइन करने में यानी एज अ सिस्टम इंजीनियर काम कर सकते हैं. अगर आप मास्टर्स या PhD के स्टूडेंट हैं तो बड़े अच्छे थीसिस आइडियाज़ इसमें से निकल सकते हैं आपके लिए. और हमारे पास स्टूडेंट्स की भी पोस्ट अवेलेबल हैं. अगर आप मास्टर्स या PhD स्टूडेंट हैं तो थीसिस अपना पिक करें इससे रेलेवेंट एरियाज़ में. कोई सब सिस्टम डिज़ाइन के लिए, पेलोड डिज़ाइन के लिए, मे बी इमेजिंग पेलोड, अगर आप इमेजिंग के स्टूडेंट हैं तो काफ़ी सारी इस तरह की अपॉर्चुनिटी है. और प्लस उसके अलावा भी ये क्योंकि एक नेशनल CubeSat है और पाकिस्तान का इसमें नाम है, IST का नाम है, बल्कि पूरे पाकिस्तान की तमाम यूनिवर्सिटीज़ का नाम है. तो ऑफ कोर्स आप चाहे IST से हैं या किसी भी और यूनिवर्सिटी से, आप इस चीज़ में भी शामिल हों कि आप कैंपेन वगैरह करें. तो बेसिकली दैट्स अबाउट इट। आई होप कि आपके लिए ये सेशन यूजफुल रहा होगा। आपके बड़े कुछ रेलेवेंट क्वेश्चंस भी आए, वो वाले क्वेश्चंस भी अभी हम देखते हैं, बल्कि डॉक्टर रेहान आगे अगर टेक अप करें और कुछ क्वेश्चंस के आंसर हम आपको यहाँ पे दे सकें तो बड़ा अच्छा हो जाएगा। जी डॉक्टर रेहान।
जी थैंक यू डॉक्टर खुरम। बेसिकली जो ज़्यादातर क्वेश्चंस थे सबके दे वर रेलेवेंट टू देयर पार्टिसिपेशन इन दिस प्रोजेक्ट ICUBE-N। फॉर एग्जांपल मैं उसमें एक कलेक्टिव आंसर दे दूं कि द डेवलपमेंट ऑफ एनी सैटेलाइट वेदर CubeSat or not, it is a multidisciplinary task. Multidisciplinary means starting from electrical engineer or mechanical engineer, aerospace engineer, and then from computer science or space science, all the disciplines or the students which are studying in these disciplines can easily take part in the development of this kind of satellite, or in fact in any satellite. फॉर एग्जाम्पल सॉफ्टवेयर इंजीनियर्स का कोई पूछ रहा था तो यू कैन टेक पार्ट इन द डेवलपमेंट ऑफ मिशन डिज़ाइन सॉफ्टवेयर, जो सैटेलाइट का एक ऑन बोर्ड कंप्यूटर है, तो देयर इज सम सॉर्ट ऑफ सॉफ्टवेयर इज रनिंग इन दैट, तो आप उसके डेवलपमेंट में हेल्प कर सकते हो. एंड इन फैक्ट आफ्टर द लॉन्च ऑफ द सैटेलाइट वी हैव टू रिसीव डेटा फ्रॉम द सैटेलाइट, एंड फॉर दैट पर्पस वी हैव सम सॉर्ट ऑफ mission software which is running on simple PC. So you can also be helpful in developing that kind of software. So the bottom line is that the students from various fields can easily participate in that. So this is only with respect to the development of subsystem. But from the point of view of payload, जैसा कि डॉक्टर कोरम ने बताया आपको कि the payload is the thing कि satellite actually काम क्या करेगी. So in ICUBE-N we have several options. We can include several science experiments or other payloads from the students of different universities. You can propose that, okay, I want to measure the radiation of this type, or we want to take the images of the Earth from the satellite. So the horizon is very big, that what will that satellite do. So the bottom line is you can take part in this project in different ways. और इसमें मैं एक चीज़ ऐड कर दूं. I know most of the students are not aware of the satellite engineering, although the satellite engineering is a combination of electrical, mechanical, aerospace and space science. So we are starting a series of these tutorials and lectures from starting from the very basic stuff. And after 2 or 3 weeks, we will notify you and you can start taking those lectures. So please remember to register and join our YouTube channel, and we will try to broadcast those lectures on that channel. Yes, Dr. Khurram, if you have any sort of other comment. और डॉक्टर रिजवान
जी सच तो कोई नहीं, बड़ा अच्छा डॉक्टर रेहान आपने कंक्लूड किया, और स्टूडेंट्स के क्वेश्चंस और रिसर्चर्स के क्वेश्चंस जो साथ साथ हमारे पास आ भी रहे, तो ओवरऑल इंटरेस्ट काफ़ी है स्टूडेंट्स का भी इस चीज़ में, और ये बड़ा इंटरेस्टिंग एक प्रोजेक्ट है. ऑफ कोर्स IST पाकिस्तान में वो वाहिद यूनिवर्सिटी है जो सैटेलाइट डिज़ाइन और डेवलपमेंट में थोड़ा लीड रोल प्ले कर रही है, लेकिन अब बाकी यूनिवर्सिटीज़ भी हमारे साथ इंशाल्लाह शामिल होंगी. नस्ट के कुछ लोग शामिल हो रहे हैं, UET पेशावर से हैं, NED से, काफ़ी मुख्तलिफ यूनिवर्सिटी से हमारे साथ लोग इंशाल्लाह शामिल होंगे, और होपफुली एक रियल सेंस में एक नेशनल क्यूबसेट हम बनाने में कामयाब होंगे. हमारे पास एक फैसिलिटी IST के अंदर ऑलरेडी एग्जिस्ट करती है, स्मॉल सैटेलाइट लैब SSL, जो अब SSTR में कन्वर्ट हो गई है. तो आप लोग जो IST के हैं वो कभी मेन ब्लॉक में आए और वहाँ पे विजिट करें. जो बाकी यूनिवर्सिटीज़ के लोगों ने ज्वाइन किया हुआ है वो भी ज़रूर आए और एक दफ़ा IST को विज़िट करें, लैब को विज़िट करें, जो टीम है उससे मिलें. डॉक्टर रेहान, डॉक्टर रिजवान स्पेशली, दोनों का बड़ा एक्सपीरियंस है. डॉक्टर रिजवान तो अभी स्मॉल सैटेलाइट डिज़ाइन एंड डेवलपमेंट टीम जो फिनलैंड में है उसके साथ काफ़ी लीड रोल प्ले करते रहे. तो आप लोगों को एक बड़ा अच्छा इंटरनेशनल फ्लेवर मिलेगा यहाँ पे SSTR के अंदर, और होपफुली एक अच्छा कैरियर आप बिल्डअप करने में कामयाब होंगे। डॉक्टर रिजवान, आप कुछ ऐड करना चाहिए?
यस, थैंक यू वेरी मच। तो बस मैं ये ऐड करना चाहूँगा कि इफ़ यू आर इंटरेस्टेड इन डिज़ाइन एंड डेवलपमेंट ऑफ एनी सब सिस्टम, या आपके पास कुछ आइडियाज़ हैं, तो डू कॉन्टेक्ट अस। और आपके साथ जो है ऑलरेडी यू वुड हैव सीन के कुछ स्लाइड्स पे हमने कॉन्टेक्ट डिटेल्स दी हुई थी या हाउ टू कॉन्टेक्ट बताया हुआ था। तो इन एनी केस यू कैन ईजिली सर्च अस ऑन IST वेबसाइट, all of us three, and if you have any types of questions, then please do let us know.
Okay, Dr. Rizwan or Dr. Khurram, I'm very thankful to you and all the participants. Just to conclude, do remember these three things. We will educate you, we will provide you a training equipment, and we will involve you in a real satellite development project. So do join us. Thank you very much. Allah Hafiz.